What are the use cases for quantum networks with quantum memories? Well, one of the use cases is this whole idea of performing a much more highly secure infrastructure. Again, the idea behind protecting us from harvest now, decrypt later threats. In other words, if somebody is monitoring your information flow between two data centers, for example, and collecting that information today, there's nothing they can do with it today. But if they've captured the public key that was exchanged as part of the initial infrastructure and secure connections setup, they'll be able to crack that public key with a quantum computer sometime in the future, and then be able to unravel all of the information that was sent across that link and stored and harvested. So performing these highly secure private networks is critical. And these networks can be used to secure site-to-site locations. Again, they may be used to go from headquarters to a data center. They may be used from headquarters to campus locations. There's a wide range of connections that can be secured. A second use case is this concept of data center to data center communication. Again, data centers are connected oftentimes together to perform backup, to perform redundancy, to share data. They're also used to protect against ransomware attacks. So if I can store data in a different format in a separate data center, and I can retrieve that if the first data center, for example, gets compromised by ransomware. So performing the connection between those data centers or between data centers and even cloud providers is critical. Another use of these quantum networks using quantum memories is within the data center itself. So as many of you know, classical data centers use classical servers and computers. Those classical servers and computers are connected to one another. Sometimes they're using leaf and spine networks, but they're all interconnected. And oftentimes 60% of the data center is using classical computers, 30% is using some form of networking, and 10% is using security. We will see the same thing occur with quantum computers and quantum memories that are adjacent to those quantum computers. We will begin to see data centers that are built out with multiple quantum computers, and those quantum computers will need to be interconnected with one another. As I mentioned earlier, operating in the qubit realm requires us to maintain the qubit integrity and state and carry that to another quantum computer or even quantum memories in that quantum data center to be able to maintain the fidelity and maintain the quantity of data that's contained within those. So another third use case. The exciting thing is that these technologies, whether they're the quantum memories and the quantum repeaters, quantum devices, can work in conjunction with existing classical networks. And the quantum networks obviously use and leverage the laws of physics, using physics in some cases to solve very complicated problems. In the case of networking, using physics to connect qubits, but also using physics to fight physics, quantum physics, which is being used to potentially hack math-based algorithms. So very exciting use cases and a wide range of capabilities that can be supported.